This will change everything 10 tech trends in 2025. In this video, we will show you 10 game-changing tech trends that will not only define 2025, but will also transform how we live, work, and interact with the world around us. Number 10. Agentic AI. In artificial intelligence, Agentic AI signifies a paradigm change from tools that need human guidance to self-governing systems that can make decisions and carry out tasks on their own. Agentic AI functions with some degree of self-governance, able to assess complex data, define goals, and adjust methods on the fly, in contrast to standard AI models that support or enhance human operations. These agents are capable of managing complex workflows in a variety of industries, including supply chains, where they can negotiate with suppliers, foresee changes in demand, and make real-time logistical adjustments without the need for human intervention. Agentic AI in customer service may answer complicated questions by utilizing several databases, gaining knowledge from previous exchanges, and elevating problems only when required. This independence significantly boosts productivity, lowers operating expenses, and enables companies to expand operations with little human supervision. Number 9. Neurological Enhancement. Bidirectional brain-machine interfaces for neurological enhancement have the potential to completely transform how people think and interact with technology. By creating a two-way channel of communication between the brain and external equipment, these interfaces have the potential to improve memory, concentration, and problem-solving skills, in addition to allowing control of computers or prosthetics. For instance, a knowledge worker with BBMIs may use neural signals to directly access large databases or computational tools, greatly speeding up learning and decision-making. Early clinical uses concentrate on helping impaired people regain their motor or sensory abilities. But the technology's potential to improve cognitive function in healthy users is also growing. This creates regulatory issues as well as serious ethical concerns around equity, consent, and privacy. Number 8. Quantum computing breakthroughs. As quantum computing moves from theoretical study to real-world implementation, it holds promise for resolving issues that traditional computers are unable to handle. By taking advantage of concepts like superposition and entanglement, quantum computers enable qubits to represent several states at once and carry out parallel computations at previously unheard-of rates. It is anticipated that improvements in scalable architectures, error correction techniques, and qubit coherence times would make quantum advantage a reality by 2025. This enables sectors like pharmaceuticals to model molecular interactions at the quantum level, speeding up tailored therapy and medication development. Quantum algorithms have the potential to improve fraud detection and portfolio optimization in the financial industry. Number 7. AI integration in everyday life. Artificial intelligence is becoming an inconspicuous yet essential component of daily life, woven into the very fabric of how societies operate. In the medical field, AI-powered diagnostic systems examine genetic information, medical imaging, and patient histories to identify illnesses early and customize care for each patient, improving outcomes and cutting costs. The use of AI tutors by educational systems makes learning more efficient and accessible globally by adjusting to the learning preferences and speeds of individual students. Through predictive analytics, smart cities use AI to optimize energy use, control traffic, and improve public safety. Artificial intelligence-powered autonomous cars hold the potential to revolutionize urban mobility by lowering traffic and accident rates. Number 6. Smart wearables. Wearable technology is changing dramatically, progressing from large timepieces to more understated, multi-purpose gadgets like smart rings and spectacles that fit in with everyday life. In addition to providing safe contactless payments and smart home controls, these small and fashionable smart rings offer continuous health monitoring by monitoring oxygen saturation, heart rate variability, sleep patterns, and stress indicators. Their discreet nature makes them perfect for people who prefer technology that does not interfere with their lives. With the help of augmented reality and artificial intelligence, Smart glasses may project digital data into the actual world, providing real-time translation, navigation, and contextual alerts without requiring users to glance at their phones. Number 5. Humanoid robots and automation. The ability of humanoid robots to interact with people in natural ways and carry out intricate activities in human-designed surroundings is developing quickly. With sophisticated sensors, artificial intelligence, and agile manipulators, humanoid robots are able to navigate dynamic environments, identify human emotions, and react accordingly. In contrast to standard industrial robots that are limited to repetitive tasks in controlled environments. These robots can respond to labor shortages and improve client experiences in service industries, including hospitality, retail, and healthcare, by greeting customers, giving information, helping with mobility, and carrying out cleaning or delivery duties. Humanoid robots are used in manufacturing to assist automated assembly lines by doing delicate or variable activities that call for flexibility and fine motor abilities. Number 4. Green technology and clean energy. 2025 will be a crucial year for sustainable development because of the global imperative to tackle climate change, which is speeding up innovation in clean energy and green technologies. Renewable energy-generated green hydrogen is becoming a flexible and clean fuel substitute for hard-to-electrify industries, including heavy manufacturing and long-distance transportation. Green hydrogen is becoming economically feasible due to cost reductions brought about by improvements in electrolyzer technology and production scaling. The development of compact modular reactors, which provide safer, more flexible, and more affordable power generation and can supplement intermittent renewable sources like solar and wind, is also contributing to the resurgence of nuclear energy. In materials science, circular economy models encourage resource efficiency and waste. Number 3. Next-gen digital identity and payments. Systems for digital identification and payments are changing, improving security, privacy, and user ease for people all around the world. Mobile driver's licenses are taking the place of paper identification, enabling users to use cell phones with cryptographic safeguards to digitally confirm their identities and prevent fraud and identity theft. These digital IDs streamline bureaucratic procedures by enabling easy access to financial transactions, travel, and government services. In the meanwhile, QR code-based payments have proliferated, particularly in developing nations, facilitating quick, contactless, and inexpensive transactions that promote financial inclusion for those without access to banking. Number 2. Space technology. The ability of low Earth orbit satellite constellations to deliver fast, low-latency internet connection to even the most isolated and underserved regions is revolutionizing international communications. LEO satellites orbit between 500 to 2,000 kilometers above Earth, greatly lowering signal latency and enhancing connection quality in contrast to conventional geostationary satellites, which are positioned about 36,000 kilometers above the planet. Businesses like OneWeb, Amazon's Project Kuiper, and SpaceX's Starlink are putting thousands of these satellites into orbit, forming a dense network that guarantees constant coverage over the globe. In order to grow the Internet of Things and enable real-time disaster response systems, smart agriculture, and environmental monitoring, this connectivity is essential. Number 1. Neuromorphic Computing. Neuromorphic computing is a novel method of information processing that mimics the architecture and operation of neural networks seen in the human brain. Neuromorphic chips use networks of artificial neurons and synapses to process information in parallel, enabling quicker and more energy-efficient processing than traditional computers, which process data sequentially and use a lot of energy. For AI applications like autonomous cars, robotics, and edge devices that need real-time learning, pattern recognition, and sensory processing, this architecture is especially well-suited. Neuromorphic systems are more resilient and adaptable than traditional AI accelerators because they may change dynamically in response to shifting inputs. It is anticipated that developments in materials science, chip design, and algorithms will bring neuromorphic computing closer to commercial feasibility by 2025, paving the way for smarter, more responsive devices with lower power and latency requirements. Together, these developments signal a move toward more autonomous systems, closer human-machine interaction, and a more interconnected, sustainable society. Thanks for watching our video, and don't forget to subscribe.